So this is a short little video on the last bit of notes from our complex numbers and imaginary numbers. This is I to a power. So you will never give me I to any power. Let me just jot that down. Okay, you will never give me I to any power. We have the following that will occur. So what we hopefully all know is I is equal to the square root of a -1. Okay, that's what I represents. Now, if I was to square I squared, square I, and to square this, I'm going to end up getting I squared is equal to a -1. That's what I get when I square both sides. So instead of an I squared, we saw the other day that you would give it to me as a -1. Well, what would happen now if I times this one by I and this one by I? I would get I to the third is equal to, and a -1 times I is -I. So an I to the third power can be rewritten as a -I. Okay, now, what would happen if I came to this right here and I squared this, which gave me an I to the fourth, and I squared this, which gives me a 1. So anytime I have I to the fourth, that is really going to be a 1. Now, if I continued this pattern, and let's say I times this side by I and this side by I would get I to the fifth is equal to I. You see, I'm back up here. Then if I times both sides of this by I get an I to the sixth, and then an I times an I is an I squared, which is a -1. So you see, I'm now back to -1 again. And if I did I to the seventh, where I times the I to the sixth by an I, and the other side by an I, you see I get a -I, which is what I cubed is. And if I did my I to the eighth times the I to the seventh by I, and I times a -1 I by I, get I to the second, which is a +1. So you see, I'm getting the same values here. This is I, then I got a -1, then I got a -I, then I got a 1. And then I got an I again. Then I got a -1 again. Then I got an I squared again. And then, I'm sorry, a -1 I again. And then I got a 1. So what's happening here is I to a power is in cycles. I to a power is in cycles of 4. So you need to understand the following. I, -1, that's the next one, -I, and then 1. This is our cycle of 4 for I to any power. So you can sit here and go, this would be I squared, I cubed, I to the fourth, I to the fifth, sixth, seventh, eighth, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th. You can go through that and continue, or you could figure out where you are in the cycle. So what we're going to do, for example, is you're going to divide the exponent by 4 to see what the remainder is. The remainder is going to tell you where we are. Just move this over while I'm writing on the edge. What the remainder is. So the reason being is, just kind of as a quick example, let's say I had I to the 10th. Okay, I can sit here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But since I know it's in groups of 4, okay, how many groups of 4 go into here? Well, 2. So if I was to take 10 divided by 4, okay, I would have it go in, let me do it this way. 4 goes into 10 twice, which is 8, and I'd have a remainder of 2. So having a remainder of 2 would put me right here at -1, because I'd really be here at the I squared. I was off by 1, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I was off by 2 from my cycle of 4, okay? So that was just kind of a quick little example. So let me just write out the following. So this is the pattern, yes, but how do we get that? So I'm going to write it in 2 different ways. So if you divide by 4 and have the following happen, you have a remainder of 1, a remainder of 2, a remainder of 3, or a remainder of 0 because it went in evenly, okay? What's going to happen is you're going to be at I, you're going to be at -1, you're going to be at -I, you're going to be at 1. If you're doing this with a calculator, and instead of doing like long division and finding your remainder, you do the following. If it's a remainder of 1, you would have ended up with some decimal with a 0.25. 25 is 1 out of 4, remainder of 1 out of 4. So that would have been your I. You were off by 1. If you did your division and you had a decimal of 0.5, which is 2 out of 4, that puts you at -1. If you had a remainder with a a decimal answer of a 0.75, that's 3 out of 4, which is a -I. And then if it went in evenly, so it's like a 0, then that's at a 1. Okay. Now I am going to give us a couple of examples. I'm going to add a page. So, for example, if they gave me a to the 23, 2 ways to think about it. 4 goes into 23 5 times, which is 20, with a remainder of 3. So remember, remainder of 3 is going to put me right here. So I know that the answer to this is going to be -I. Now, I also could do this on my calculator and take 23 divided by 4 on my calculator and do that math. And when I take 23 divided by 4 on my calculator, I get a 5.75. So see that 0.75? That 0.75 was a 3/4. So again, I still have my answer of a -1. Okay. So this one is a remainder of 3, which leads to a -I. This one is a decimal of a 0.75, which also leads to a -I. So my answer is -I. If I had I to the 54, let's say. Again, I can do it either way. I can go 4 goes into 54 and kind of think about it that way. Well, 4 goes into 5, 1 switches 4. I have a 1, bring down my 4. 4 goes into 14 3 times, which is 12. And I'm going to have a remainder of 2. Okay. Or I can take 54 divided by 4 on my calculator, and I get a 13.5. Now, either a remainder of 2 or a 0.5, remainder of 2 or a 0.5, both give me a -1 back. So this answer here is a -1. And that's just a couple of examples that I want us to add in so that we have these in our composition book.